Welcome back, everybody. This is episode 13 of my multi-cloud network architecture series. I can't believe we're on the 13th episode. We've had so much awesome content over the last couple months, and we have so much more coming. Today, we're going to talk about these third-party interconnects that organizations such as Megaport and Equinix are offering customers. Recently, I've had a lot of my customers asking me about how they can integrate and leverage these third-party interconnects with the Aviatrix multi-cloud network architecture and networking platform. What can we get out of them? What can we add to them? How can we make their lives easier when it comes to consuming and operating these third-party interconnects? How do we get the most out of it? So today I've invited special guest Tomasz Klimczyk, my buddy from Barcelona, to show us what he's accomplished with Aviatrix and third-party interconnects. Thank you so much for being here with us today, Tomasz.
Thanks, Dana. It's a pleasure to be here. My name is Tomasz Klimczyk. I'm one of the solution architects working at Aviatrix, based out of Barcelona. As you said, there are lots of customers asking about how third-party interconnect service providers like Megaport or Equinix can be fit into Aviatrix multi-cloud network architecture. And definitely there is a way to insert them, and over time we will be getting better and better at it. So today I would like to tell you about what we see as the version 1 of such insertion. What you see on the slide here is in part standard multi-cloud network architecture by Aviatrix. On the left side of this diagram, you see Oracle with a transit VCN and 3 spoke VCNs, all nicely interconnected. On the right side, you have Azure with a very similar architecture, a hub VNet with 3 spoke VNets. Obviously, within each cloud, all the connectivity is working seamlessly. Now, what we normally do between our hubs is to establish a peering over the public internet, because that's the easiest way to do it. There's no dependencies on any third parties. It's point and click, super easy to establish. Mm-hmm. However, as you said, there are sometimes customers that are asking about leveraging the third-party interconnects. So we have a way to insert them. And now I will tell you how this is working. Instead of building this transit peering that we normally do over the public internet, we have ways to establish peering between our gateways over the private connectivity that those third-party interconnects are providing. With this, you still preserve all of the great benefits of Aviatrix multi-cloud network architecture. You've been doing great videos on intelligent control plane, and this is super crucial to having this centralized way of managing the entire public cloud networking. So our controller plus the visibility with Copilot, this is all you're still leveraging when you're doing the interconnect this way. The only difference is that you don't establish the interconnect between those transit hubs through our standard workflow. We will use a quick workaround to enable that peering. We will build this peering leveraging BGP over private connectivity that the third party is providing. So now let me quickly walk you through in our controller UI on how this is done. So this is our UI. I'm sure everybody's familiar with it by now. Normally what you would be doing if you were building transit peering between Aviatrix hubs, you would go to transit network, transit peering, click on add new, select the left side gateway, select the right side gateway, hit OK, and establish the peering. This is super easy, but also this for now only leverages the public internet connectivity between our gateways. Now, in order for us to leverage the private connectivity that you're providing within your underlay, whatever that is, we would go to a different workflow. We will go into transit network setup. Step 3, connect to an external device. Over here, we have the BGP pre-selected. Let's keep it here. You would select your first VPC or VNet or VCN. Give this connection a name. Let's say A to B. Type in the BGP parameters. Select your primary cloud gateway. Ideally, enable remote HA. Type in the BGP number that you give to the gateways on the remote end. Type in the remote gateway, the primary IP, then the secondary IP. All of the other configuration elements are optional. feel free to fill them in. Feel free to let our controller generate those values. What is important to note over here, we need to hit over direct connect in both of those links. This will force the gateway to establish the peering over its private IP address.
Okay, got it.
So over here, we assume that you have this private connectivity already established. This can be your underlay with Megaport, with Equinix, or something that we will talk about in a second, OCI-to-Azure Interconnect. You build this tunnel from one end, go to site to cloud, download the configuration for the tunnel that you have created. It's super easy to do. You just click on the one that you have created, do download configuration. Ideally, you should just select generic, so that's easier to read, download this configuration, and then go back to the transit network setup step 3 workflow and establish this peering from the other side. So from the other transit gateway, for instance, OCI, you just have to match those values that you have from the configuration file. It's not difficult to do, super fast. And then we establish BGP-based peering between our transit hubs.
Yep. Okay, that makes sense. So I would imagine in the future, Tomasz, that we would change our UI to show something like over private connection instead of over direct connect, or maybe an additional option for that once this becomes more mature in the UI, right?
That's exactly the plan. As I mentioned before, today we're showing you the version 1 of this type of connectivity, but definitely in the future we want to improve it so that's simpler for you to build.
Yeah, I think the value here in this demonstration is to show how flexible our controller architecture really is, in that we really can meet any use case with the existing platform. And so I think that's a pretty powerful thing to talk about, that we can say, hey, I want to do it over the internet, or I want to do it over a private connection, and I don't care what that private connection is. We have that capability.
You're so true. And recently I have myself been talking with a potential customer here in Europe, a financial company. They, by regulation and by their own security rules, they don't want to leverage public internet connectivity for the important traffic. And they actually are using already in their legacy way of deploying public cloud networking, they have already been building some connectivity leveraging that interconnect. So now it's easy for us, for Aviatrix, to integrate with the setup which they currently have, just put our gateways on both ends of those private links, private circuits, and build this tunnel this way. For now, this will solve all of the challenges that they are struggling with. And in the future, we commit to making this configuration even easier.
Fantastic.
What we have not spoken about yet is what are the limitations of those third-party interconnects. There are many of them, and I would like to highlight a few. First of all, those interconnects are not encrypted. And what you see over here is an example of such an interconnect between two clouds. This is actually a very cool service between Oracle and Azure. You can set up this line over Fast Connect and Express Route. Those are private circuits of each respective cloud. Just interconnect them, and within a few clicks, you have this private circuit going from Oracle Cloud to Microsoft Azure. This actually skips the third party, but this is not very popular with all of the cloud providers. Oracle and Azure is one of the very few examples of this direct type of interconnectivity. So that's why we're talking about it over here today. As I said, not encrypted. Neither this link nor any other third-party interconnect that you may be using is encrypted. So this is a potential threat to all of the companies, especially the companies within the financial business like banks or insurance companies. They don't like having their data in transit not encrypted, or at least not encrypted in a way which they handle.
Yeah, we see that all the time for sure.
Exactly. So this is one of the first challenges that our solution, our approach is trying to tackle. Second of all, for this very specific service, it's not available in all Oracle and Azure regions. There are a few pairs of those regions worldwide where you can enable this service. But what I see as the biggest challenge in this scenario is the fact that you are creating a point-to-point link. When you're just using the native services, it's a VCN to VNet connection. And Dana, I'm sure you agree that you don't see customers that only have one network in each cloud, one VCN,
That's
one
for sure.
VPC,
Yeah,
or one
this
net.
needs to be a better scale architecture than what you have here.
Exactly. So the solution that is provided here natively is okay when you're just trying to connect those two atomic networks. But we know we will need a proper transit. And this is where Aviatrix comes into the picture. We will leverage this connectivity to establish the peering between our transit gateways. But as you remember, and as I will be showing in the next slide, that transit gateways have all the connectivity to all of the other networks, all of the other spokes that you build in the cloud. They have connections maybe to other clouds or maybe to other regions. So with the fact that on this particular link, we're leveraging private connectivity, it just completes our story. But the biggest advantage of leveraging Aviatrix is that you have this unified and normalized data plane across all of those clouds, fully connected and all centralized in the controller that manages, configures it all, provides intelligent cloud routing.
Right. Yeah, Tomasz, this is awesome information, but I want to just drive home one point here that's really important for our viewers to recognize. When you look at this feature in isolation, it's fantastic, right? The fact that we can connect these two clouds together seamlessly, get high throughput connectivity, fantastic. However, you need to look at this from the big picture. You need to think about, how does this actually fit into your network? How do you scale this type of functionality out to get the best from it? How do you make it intelligent? Because realistically, it's still just a dumb point-to-point connection. It has no intelligence, no automation built in. It's really just a manual connection you've built between these two environments. And there's a lot of problems with that. And that's where having a controller-based architecture like the Aviatrix platform provides all the benefits, right? You get all this intelligence, you get the loop prevention, you get the high availability, you get the visibility, you get the automation, you get the encryption on top. Like, you get every single thing that the multi-cloud network architecture provides from Aviatrix when you leverage it on top of a functionality like this. I just want people to realize how important it is to add intelligence to these features.
Yeah, right, Dana. Totally agree. And now let's take a look at this diagram where I place that private connectivity into the bigger picture, into the full Aviatrix transit architecture.
Okay.
As you can see, we are interconnecting transit networks, leveraging the private connectivity. There's BGP running between those networks, so it's fully dynamic. But what is crucial over here is that we have our controller, we have our visibility platform Copilot, and we have our gateways in all of the other spoke networks. So with this, you have end-to-end connectivity, all automated by our controller. Controller makes sure that the configuration on each hub is perfectly correct. If there are some issues, you have ways of troubleshooting. And Dana, you've been doing a great job in other videos showcasing those features. So I'm sure all of the viewers are familiar with them by now. And to your earlier point, Dana, let's for a second forget about Aviatrix in this picture. Let's just keep the same diagram, keep the same architecture, but forget about Aviatrix controller and forget about Aviatrix gateways. And let's try and figure out how we would do this connectivity without Aviatrix. First of all, you'll have to establish multiple network peerings, whether it's VCN peering or VNet peering, you'll have to do it manually. Then you will have to manage all of the routing tables in spokes to point the correct routes towards the hub network. In hub network, normally you don't have the transit capability natively. So depending on the cloud here in Azure, you could use some form of a NVA, network virtual appliance, to do the routing for you. Inside Oracle Cloud, you could use some of their native gateways to provide the connectivity and the transit. You would have to manage each of them. You would need to make sure they are highly available. You would need to make sure they have all the knowledge about all of the other routes in the other cloud to get this end-to-end connectivity. Plus, since you're doing everything in a native way, you don't have visibility. You don't have troubleshooting skills. You wouldn't be able to run ping easily. You wouldn't be able to run trace route, trace path, or packet capture. Our controller would not be overlooking this entire architecture. You wouldn't be able to leverage the flight path, a feature that you have highlighted in some of your videos already. Great tool to do troubleshooting. So those would be all of the things you would be giving up if you were not using Aviatrix here.
And you'd also be missing out on any flow visibility, right? That's a huge piece. Copilot provides this really in-depth view on flow visibility as well as dynamic topology building, right?
Totally right. We have a great set of visibility tools built into the Copilot platform, starting from NetFlow collection and presenting all of that data to a nice topological view with capabilities of troubleshooting and a general summary of all of the statuses of all of the gateways that you have deployed. Yeah. So without Aviatrix, you would either have to do all of those things manually, or you would have to hire a team of software developers with the knowledge of networking to build the automation for you. But we have been discussing it so many times. What are all of the challenges of automating your cloud networking, just leveraging the native constructs? It's a one-way street. Sooner or later, you will hit lots of challenges. And as this would be growing, you'll be basically having all of your most experienced people troubleshooting the most basic issues because nobody else would understand all of those automation that they have built.
So, Tomasz, I know we've been focused on the OCI and Azure private connectivity model. And of course, this is supported and works on any other private peering model, right? Anything from Equinix or Megaport or whatever, all these other guys out there doing the same thing, we would support it because it's just underlay we're building an overlay on top of. And so I'm actually curious about what this looks like from the bigger picture. As a cloud network architect, I'm more interested in how does this look when I'm putting this into an existing network architecture. And so an existing network architecture has all sorts of other things in it already, right? So do you have anything you can show me around that?
Great question, Dana. I actually do have something to show, a slightly bigger picture with a slightly more advanced architecture. As you can see with Aviatrix, all of this networking is modular. So now it's up to you to decide whether you want to use private circuits, as we have used here to interconnect OCI and Azure, or public internet to interconnect your regions. In this case, we have used public internet to interconnect AWS and OCI. Actually, I have a few ping sessions running between AWS and OCI, and also OCI and Azure. And this is all working just fine. On top of this, you can obviously start inserting other Aviatrix services, firewalls, FQDN control, high performance encryption everywhere, interconnectivity to your branches, your data centers. Okay. The architecture is very flexible. It's very modular, and all is automated through our controller. So you have this great set of tools to configure everything in an automated way to make sure that the network configuration is correct and that you have a great set of troubleshooting tools to get the visibility when you need it.
Right. I think that's such an important point to drive home, that we have this controller solution that's allowing this agility so you can easily bolt on additional components of the cloud network without affecting anything else. But this controller is ensuring that you're adhering to this validated architecture so that you can scale out, you can be repeatable. It's just a beautiful, beautiful mechanism that we've built at Aviatrix.
Totally agree. Couldn't say it better. As a bonus, let me quickly touch on the subject of the insane mode, or the official name, high performance encryption. This is a service that allows Aviatrix to build high performance tunnels fully encrypted between any Aviatrix gateways. This is something that, as you can see, in AWS, we have verified to get up to 70 gigs worth of throughput fully encrypted within a region between two networks. Very similar performance results for Azure. Now, what you see over here in the middle, we can also implement high performance encryption, insane mode. And over here, the only thing that's limiting us is the line rate of the underlay. So now it's up to you what you want to select as this underlay. We can go over the public internet, or we can use your private circuit, something like OCI to Azure Interconnect, or something like Megaport Equinix, this third-party service provider, to build this underlay, on top of which we would build a high-performant, fully encrypted pipe interconnecting your cloud resources.
Tomasz, this is awesome. I'm so excited for our next revisions of code where we've orchestrated all of this private interconnect connectivity and where we can get that super high throughput encryption using our technology, insane encryption, on top. It's going to be amazing. It's going to be unbeatable. We're already unbeatable. We're going to continue to make this product even more unbeatable. I'm so excited. I really want to thank you for being here with me today.
I had a great time being here. I've been watching your videos all this time, and now finally I got a chance to be here. So woohoo, great stuff.
For sure, we'll have you on some future videos as well. Thanks again. All right, as always, I like to leave you with a slide that summarizes what did Aviatrix do for you in this scenario. Tomasz showed us how we could leverage these high-speed private interconnects to build transit connectivity, but not just to build them statically, but to build them with intelligence, to enable enterprise functionality and visibility and automation, to add functionality on top like end-to-end encryption, dynamic route propagation, and much more. Since you're onboarding this private connectivity into your Aviatrix multi-cloud network architecture, you can then benefit from everything else this platform offers, including the intelligence, including the visibility, including the end-to-end segmentation, the easy repeatable architecture, the fact that you can bolt on and remove these pods or modules without affecting anything in the network, and the fact that you can then insert additional services like next generation firewalls through total automation, zero effort from the end users or network operators perspective. And now that you're riding the multi-cloud network architecture, you get the full functionality for troubleshooting like packet capture in really strategic places in the network, ping and trace route, trace path, flight path, and Copilot. Copilot I'll show you in a future video. We got a lot more coming in this series, so please subscribe, stay tuned, and share this with everybody in the cloud networking world. Thank you for watching. We'll see you next time.